Here we go with the unit vector. A unit vector is a vector that has a magnitude of 1. A vector and its unit vector will be going in the same direction, which means they would have the same degrees, but they are going to have different magnitudes because they're different sizes. A unit vector is really small. Notice it has just a magnitude of 1. To find u, by the way, a unit vector is always denoted by the letter u. If you see the letter u, it's probably a unit vector. You're going to divide v by its magnitude. All right, there is one more formula that you have to memorize. However, I am going to rewrite this formula in a way that is a little bit easier to understand. So on the top is for sure the vector, but we love vectors in component form. So this is still A, it's just plain A, plain B on top. Plain A, plain B on top. But it's divided by its magnitude. And I'm just going to write the formula for magnitude, a squared plus b squared, underneath that square root symbol. So that's how we're going to find the vector, the unit vector. The unit vector has two components. I wrote this as one fraction, but there's two pieces. So what I'm going to do is I'm going to break up this fraction when I do my actual work, like this. Here's A. Here's B. I'm breaking them up because they're going to be separate anyway, and they're all going to simplify in different ways. So just break them up and make it easy. They are going to have the same denominator, though. This is going to be negative 2 squared plus 5 squared. All right, so I'm going to clean up the bottom here. Just going to recopy the top. So that's going to be a 4 plus 25. That's going to be the square root of 29 down here. Now, the square root of 29, nothing can come out. However, just like every other thing we do in pre-cal, if you have a square root in the denominator, you have to rationalize it. And y'all are really good about the shortcut. So when this is rationalized, I'm going to write my final answer up here because I ran out of room. So u for unit vector. And this is going to have a numerator of negative 2 root 29 over 29, comma, and then the other numerator is 5 root 29 over 29. And my work got a little messy, so I'm going to just highlight that answer so it doesn't kind of blend in with my work. And that's how you find a unit vector. Let's do it again. We're going to go a little quicker this time. All right, I have vector v. I'm going to break up its components. This is going to be 49 plus 9 on the bottom. And that's going to be the square root of 58. There are not any perfects in the square root of 58, so we can go straight to rationalizing. However, on a test or a quiz, I'm not going to tell you that. So I'm sure you guys know this. I just want to make sure everybody knows. To figure out if there's a perfect square, you take that 58 and you start dividing by perfect squares. 2 times 2 is 4. That's not a whole number. So I try the next one. 3 times 3 is 9. That's not going to work. Next one, 4 times 4 is 16. Whoops. 58 divided by 16. That's not a perfect square. So that's the way that you can make sure on your own on a test or a quiz. Divide your number by perfect squares. All right, let's write this in vector form, component form. Positive 7 square root 58 over 58. Negative 3 root 58 over 58. And that's how you do your unit vector. All right, what's next? The same thing. It's just written in linear combo form. Same exact thing, just written in a different form. So let's knock this out fairly quickly. Let's go ahead and write it in component form. 4, 2, that's the vector. Break it up. So on this one, guys, when you square those numbers, it's going to be 16 plus 4. And 16 plus 4 is 20. And I think all of us know there's a perfect in 20. That square root popped up a lot in last unit. Remember, 4 times 5 makes up 20. I'm going to take that 4 out by its root. Those whole numbers, that 4 on the top and that 2 on the outside of that radical, those are going to simplify. So remember, the key to make this smooth is to simplify as you go. This, I'm going to cancel these out. I'm going to cancel these out. 4 divided by 2 is 2. This is going to be 2 over the square root of 5. This is going to be 1 over the square root of 5. And then don't forget, you got to rationalize the denominator. So your unit vector is going to be 2 square root 5 over 5. 1 square root 5 over 5. I'm a little sad I wrote that 1. I didn't need to write that 1, but I did. But don't box that in because it's in linear combo form in the beginning. So we're going to write the unit vector in linear combo form. And I'm going to kind of write over this space. We're not going to do number 6 because it's the same thing. So here's my unit vector in linear combo form. 2 square root 5 over 5i plus square root 5 over 5j. All right, so we did 3 examples on unit vectors because it's a tool. It's one of a multi-step process to get us to the next part. Look at numbers 7 through 10. Find the vector A with a given magnitude and the same direction as vector V. So notice I'm already given the magnitude of vector A that I'm trying to find, but I know it goes in the same direction as vector V. So what we're going to do is we are going to find the unit vector. That's why we just practiced it 3 times. It needs to be just a tool in our toolkit. Then we're going to multiply by the magnitude. So guys, again, it's not crazy hard math, but there's a lot of simplifying going on in this. Lots of taking out perfect squares. Lots of rationalizing the denominator. So if I can give you any little tip on this section, it would be to simplify as you go. That's all I got for you. That's the best thing I can do. Okay. Here we go. Finding the unit vector of V. There it is. So I'm going to break up these positive 3 and negative 3, negative 3 and positive 3. Do the little whole square root business thing again. That denominator turns into the square root of 18, and there is a perfect in that. Okay, don't forget that 9 times 2 is 18. We're going to take that 9 out by its root. And see what I mean here? You got to keep simplifying. All those 3's are going to cancel. I kind of ran out of room, so I'm going to scoot my work over right here. So this is going to be negative 1 over root 2, positive 1 over root 2. I have to rationalize the denominator now. So here's what the unit vector is. And remember, this is just a toolkit. This is not my final answer. Negative square root 2 over 2, positive square root 2 over 2. But the hard work is done. Once you get to that part, you just multiply by the magnitude. Remember, the magnitude is 6. So this is going to be 6 times the square root of 2 over 2. And then the other one was positive. And again, 6 over 2 can be simplified. So the unit vector that they wanted us to find, remember they wanted us to call it vector A. So I'm going to write it right here. I'm going to use my symbols. And I'm going to write it in component form. This is going to be negative 3 square root 2, because 6 divided by 2 is 3, positive 3 square root 2. So that's the answer. So you find the unit vector and then you multiply to find the magnitude.